Tina slowly, slowly. We be working all day long, the push us bunny. We ain't playing no games, Sabatavi, Gani.
A good day, grade 12. I hope you are good. Today we're doing trigonometric equation where you are going to remember all your algebra here, because it's more like you are solving for x, but since here they replace x by a cos and a sine and a tan. So guys, in grade 11 you learned how to solve trigonometric equation. So today we are going to revise the basic concepts. So to find the general solution, guys, of trigonometric equation, let's say we are given like this in this form. Let's say sine alpha is equals to p and the cos alpha is equals to p, and the tan alpha is equals to p. So guys, the first thing here you must do when you are dealing with general solution, you have to find your reference angle. So how do you find your reference angle? We said in grade 11 you apply the inverse of sine, the inverse of cos, the inverse of tan. So guys, so if I apply the inverse of tan and inverse of cos and inverse of sine, so whenever I'm applying the inverse to the numerical value of let's say of p, I must ignore its sign. So let's say here, in order for me to get the reference angle, I will say alpha, the reference I'm going to say reference angle is going to be inverse of sine p. That's how you get your reference angle. So guys, then the next thing you need to do, you have to look at the sign of the given of this numerical value and the given trigonometric ratio to determine in which two quadrants the solution must be according to your cast diagram. Guys, we know that whenever we're working for sine, if this we have maybe sine alpha is equals to 1 over 2, we know that this numerical value, guys, is positive. So the first thing that I need to do here is to get the reference angle, and then I ask myself, where do we find sine positive? We find sine positive on which quadrant? Quadrant 1 and the quadrant 2. Bear in mind, guys, here we have theta is equal to reference angle plus k to 360 degrees. Then we know that your reference angle, you already found your reference angle for your first step. And then you go to quadrant 2 where sine is positive, to say 180 minus your reference angle plus the k 360 degrees. So guys, for cos and the sine, we use this period 360 degrees. For tan, we use 180 degrees, but we do the same work, ne? We do the same thing, but for tan, guys, you can use 360. We are going to explain more why you are going to use that 360. But if you used 180, it's fine. Stick to 180 degrees. Don't change that. So let's say, and also, guys, for this quadrant, you must be careful with this quadrant, and guys, and also the another thing that you need to note here, guys, that for sine alpha equals to p and the cos alpha equals to p, the value of p, guys, the value of p must lie between a -1 and a +1. So in other words, the value of p must be an interval of a -1 and a +1. So if this p is bigger than +1 or lesser than -1, there will be no solution for sine and the cos. So which means p, guys, must be greater or equals to -1 but less or equals to +1. So these are your interval. So if I have sine alpha, let's say it's equal to -2, or cos alpha is equals to +4, there will be no solution for this general solution. You will just say no solution, because sine and the cos, or if you are dealing with a cos, you're going to say there's no solution for this because cos lies between -1 and the +1. the interval of this one. The interval of P must be between this interval. So then, guys, if we have maybe cos alpha is equal to negative 1 over 2. Do you see this reference angle, guys? This value, numerical value, is negative. You're gonna get your reference angle first by ignoring the sign and go where cos is negative. We know that cos is negative on which quadrant? Third and the second. So you are going to get your reference angle first, then you come and get other two solutions. Are we together? So let's take this one as our first example, just to remind you guys. We have this one. So the first thing that I need to do here, guys, I need to apply the reference angle. So I'm going to say reference angle is equal to cos, then I take this angle, this numerical value, then I ignore the sign. So I'm going to put 1 over 2. So then I close the bracket. Then what do we get, guys? Inverse of half, which is 60 degrees. That's your reference angle. And then you go to the quadrant one, guys. It's a reference angle plus the period. So I'm going to say now in this case alpha is going to be 60 degrees plus k to 360 degrees, where k is the element of integers. And then we find other two solutions because this one is negative. Understand? So if it was positive, we're going to find only two solutions. So since it's negative, we need 3. So where do we find cos negative? We find cos negative on which quadrant? A second and the third, we said. So I'm going to say here, we are working with alpha. I'm saying quadrant 2, guys, we have 180 minus the reference angle. So I'm going to have here alpha is equals to 180 degrees minus your reference angle in this case, which is 60, then plus the period is k to 360 degrees. So what do you get here? It's 120 plus k to 360 degrees. Okay, let's change the marker. 360 degrees, where k is the element of integers. Understand? So then, and we know that cos again is negative on third quadrant. So then I'm going to say quad 3. So quadrant 3, we have 180 plus the reference angle. Then we have the period for cos. So which is alpha is equals to 180 plus 60 plus k to 360 degrees. So this one is going to be 240 degrees plus k to 360 degrees, where k is the element of integers. Don't forget this. Understand? So these are your solutions, guys. You must note that if the numerical value is negative, you must have 3 solutions. But if it is positive, you will get 2. Understand? For one trig ratio, for one given trig ratio. Let's say, for example, 2, guys. What do we have? We're gonna need this. So let's say we have let's say, for argument's sake, guys, let's say we're given tan 3 theta minus 1, 5 equals to negative 2, 5. Understand? So I'm solving for theta, guys, here. If I solve for theta, can you see, guys, this sign? Okay, let's use the red one so that you can see. Can you see, guys, our numerical value here is what? Is negative. So we need to go to find the reference angle first, and we go to the quadrant where a tan is negative. Understand? So the first thing here I'm going to say here, the first thing I'm going to do, guys, I'm saying reference angle equals to arctan or inverse of tan, then I take this numerical value, then I ignore the sign, then I say 2,5. So in this case, our reference angle, inverse of tan 2,5, it's 68, if we round off to 2 decimal, which is 20 degrees. That's your reference angle, good people. Remember, if we apply the inverse of tan here, guys, we are going to be left with this angle. Understand? So then we go where tan is negative. So we know that tan is negative on quadrant 2 and 4. Understand? So I go to quadrant 2, guys. If I go to quadrant 2, I'm going to take this angle, guys, and use my reference angle because this one is theta, guys. So theta now in this case will be 3 theta minus 15. So I'm going to say 3 theta minus 15. Understand? So that's my theta, guys. I hope you understand, guys. So this is, it says theta is equal to 180 minus your reference angle. Understand? So now in this case, guys, our theta is 3 theta minus 15. So we're gonna say equals to 180 degrees minus your reference angle. So your reference angle is 68,20 plus the period. Since we're dealing with tan, guys, we said for tan we're going to use 180 degrees, but if your teacher use 360, it's fine, you can use 360. So it's k 280 degrees. So here, guys, where we don't forget that where k is the element of integers. So what do we need to do, guys? We have to transpose this one to this side, guys. So I'm going to be left with 3 theta. So if we take 180 minus 68, 180 minus 68,20, we're going to get 111,80. Then we transpose 15 to that side. So 15 is going to be a positive. So you're going to say plus 15. So we get 126,8 degrees plus your period, guys, which is 180 degrees, where k is the element of integers. Remember, good people who are solving for theta, what do we need to do? Remember, for your algebra, that's why I was saying you must remember your algebra. If I have a 2x is equal to 4, what must I do to get x? I have to divide by 2 both sides. So in order for me to get theta here, I have to divide both sides by 3. So I'm going to say divide by 3, divide by 3. Remember, if I divide by 3, I will also affect the period. So I'm going to divide here also by 3. Understand? So now we have the solution, which is 126,80 divided by 3. So we get 42, this is going to be 7 degrees plus a k. So we go to 180 divided by 3. So this is 60 degrees, where k is element of integers, guys. So we find that because tan is negative to this quadrant, and also is negative to which quadrant? 4th quadrant. So we need to go to quadrant number 4. So then I will say again quadrant 4. So quadrant 4, guys, we're gonna say it's theta again. So we know that our theta in this case is 3 theta minus 15. So I'm going to say 3 theta minus 15 degrees is equals to 360 degrees minus your reference angle, guys. So your reference angle is 68,20 plus your period. So we are dealing with tan, guys. So I'm using 180 degrees, where k is the element of integers. So this is going to be 3 theta minus 15 degrees. So if you say 360, minus 68,2, and see what you have is 291,80 plus a k to 180 degrees, where k is the element of integers. Guys, you have to transpose this one to that side. Understand? you are going to do the same steps. We're going to perform the same steps. So it's going to be 3 theta is equals to, if we transpose here negative 15 to this side, the sign is going to change to become positive, so plus 15. So you are going to get a 3 of 6,80 plus k to 180 degrees. So we are going to divide by 3 so that we can find a theta. So therefore, if we divide by 3, we get 102,27 degrees plus k. If you divide 180 by 3, you get 60. Then where k is the element of integers. Understand? I hope you do, guys. I hope you do understand. This is the basic concept that you did in grade 11. So these are our solutions for now. These are your solutions. So for tan, because the numerical value here was negative, if it was positive, the only thing that we need to do is to find the reference angle and go where tan is positive only. But now it was a negative. So this is the basic concept, guys, you need to remember. Because in grade 12 we are going to introduce again the double angle, the compound angle when we are working with general solutions. So this is the basic concept of grade 11. So thank you guys for watching. So we're gonna do the most interesting question, the more questions in the next video. Please stay tuned. We're going to do interesting questions, the typical exam questions for grade 12. Stay tuned. Thanks for watching. If you didn't subscribe, don't forget to subscribe. I'll see you next time.